To support our discussions with the world's leading thinkers, please see the video description or visit eism.eu/support. Thank you.
Hello and welcome to A Theory of Everything. Today, as part of our leadership series of interviews, we have the privilege of talking to Michael Freedman, the Fields Medalist and original mastermind behind Microsoft's topological quantum computing strategy, which he launched and personally directed for many years at Station Q at Microsoft. We're going to talk about something of special interest to us at EISM, which are the physical foundations of management theory in general and voting theory in particular. As usual, I'm going to take a couple of minutes to highlight the most important aspects of our exchange. If you prefer to skip this introduction, feel free to jump around using the timestamp in the video description. Freedman was awarded the Fields Medal, which is often referred to as the Nobel Prize in Mathematics, for solving the Poincaré conjecture in 4 dimensions. Friedman's work is extraordinary on many different levels, but what's most important and relevant for us today is his recent collaboration with Glenn Weyl, an economist and fellow colleague of his at Microsoft Research. Freedman and Weyl, along with a string theorist collaborator named Weyl and Fabinger, recently published a paper positing a quadratic wormhole, or a connection between quantum theory and political theory. As far as I'm concerned, this paper represents the most promising breakthrough in the history of political theory, if we judge an idea by its ability to protect humanity from destroying itself. The primary advantage of founding one's politics and ethics on physics and math is that it lends itself to less disagreement than systems built on conventional opinion. On a planet full of nuclear weapons and irreconcilable opinions, the last thing the world needs is another opinion. What we need is a better way to resolve our differences of opinion, and that's why today's exchange is important. Let me repeat that idea for the sake of clarity. On a planet full of nuclear weapons, we don't need any more opinions. What we need is a better way to resolve our differences of opinion, which is a question that rests on a higher and much more important level of abstraction. The survival of our species depends on a clear understanding and resolution of this dilemma at the right level of abstraction, which reason dictates is rooted in fundamental physics. That, in any case, is the claim, and that's what makes today's exchange extraordinary. Having said that, I hope you don't get me wrong. I'm really unhappy with myself for the way the interview turned out, which is not fair to Freedman's work. I hope you'll take it as my very poor first attempt to say something meaningful about what I think is a historically significant development. Despite my shortcomings, Freedman has expressed an openness to returning, so I hope to have him back to continue talking about these important ideas and about his fascinating personal and family history. We'll also talk about another paper in which Freedman derives the universe from a single particle and the implications of that derivation for management, religion, politics, and long-term human survival, which is where I think Freedman's work dovetails nicely with our own. As always, you'll find a timestamp and relevant links in the video description, including a link to Freedman's complete biography and links to Weyl's work on quadratic voting and quadratic financing. If you think Freedman's work or my take on his work is all wrong, please let me know. I'd love to have you on as a guest. Thanks again for your interest, and here, alas, is my exchange with Michael Freedman. Dr. Freedman, welcome to the channel, and thank you so much for taking the time to talk.
Well, thank you. It's a pleasure to be here, Louis.
Well, I'd like to start by saying how happy I am about the fortuitous event that brings us together, which is your recent paper with Glenn Weyl and Michael Fabinger, where you posit a wormhole between quantum mechanics and economics. I had the good fortune of coming across Glenn Weyl's work on quadratic voting, I think about 10 years ago, and have been a big fan of his ever since. In fact, at the moment, through EISM, we're dialoguing with his foundation to explore ways of spreading his ideas and putting them into practice here in the European Union. I've been telling Glenn for several years that quadratic voting is probably the most important idea since the Enlightenment, and maybe the most important idea ever, precisely because of its foundation in physics. Now, I wrote my doctoral thesis on the physical and mathematical foundations of management, so I felt like I had good grounds to make the claim. But given that I'm not a Fields medalist like you, I suppose Glenn was justifiably skeptical. So that's where you enter the picture, and your recent backing and appraisal of his work, which was a watershed, a beautiful moment for me. You can imagine how happy I was to see you compare Weyl to Spinoza, Leibniz, and Kant. So we're going to get out to all of this and hopefully fill in the story of what brings us together on this channel today. And I've prepared some slides for that, if that's okay, and if we have a chance to go through them. But before I ask about your story and your upbringing and those aspects of your career that have brought you into contact with quadratic wormholes, I'd like to share the first slide, in fact, to kind of set the tone for our exchange, and then we can get into a little bit about your entire career, your upbringing, your youth, and the Fields Medal, and how that relates to where you are today in terms of your career. Is that okay?
Sure, sounds great.
Okay, let me share my screen, one moment.
Yeah, I see the screen now.
Okay.
Yeah.
Okay, excellent. So this is a quote that you started one of your recent talks about the quadratic wormhole on this quote from Einstein, and I think it's a very apt and appropriate and important way to begin our talk today. Can you elaborate on this idea here and why you chose to begin your talk with this?
Yeah, I was speaking to a group of economists and maybe futurists remotely, and much of the conference focused on these ideas of plurality that Glenn Weyl has been pursuing. Different ways, different ideas for enhancing the depth of our social organization. And it struck me that Einstein hit the nail on the head 90 years ago when at a disarmament conference, he bemoaned our lack of social progress compared with technological progress, and how dangerous a combination the two were. And here 90 years later, Einstein was speaking before atomic weapons, and 90 years later, we have this unsolved problem of our nuclear arsenals. One of my grown sons told me that, Dad, I'm not going to solve this problem. That's a problem for your generation. Your generation built these things. You have to figure them out. I'll worry about safety of AI and stuff like that, but you have to take care of nuclear weapons before you go. So
that's a big problem, huh?
It's a huge problem, and it's one we don't think about. Of course, the war in the Ukraine, kind of gave us a jolt. It's hard to think about possibilities that are so dire. It's the zero infinity problem, that we hope the chances of it happening are close to zero, but the consequences are close to infinity, so the human mind can't wrap itself around 1,000 holocausts,
Sure.
Which would be what it would amount to kill 6 billion people, with some estimates run that high for a full-scale nuclear war. So I just wanted to remind the conference of what the stakes were for doing their subject properly. And I think what their subject is about is how to bring people together in a less divisive and acrimonious way. And what you said about quadratic voting as one of the most important ideas, it's really a tax on extremism, if you think about it. You can place all your votes, in front of one candidate. Let's just use Donald Trump as an illustration. But if you're inflexible and it's, my way or the highway, it's one possibility, then you have a limited influence because of the distribution scheme in quadratic voting. If you have 2 or 3 candidates that are acceptable to you, you have more influence. So I really like that idea. And I first learned of it from an article in The Economist, but I noticed they quoted a guy named Glenn Weyl, who I hadn't heard of, but I noticed was in my company. And I sent him an email and we started talking and have become really good friends, though I'm going to meet him for the first time in January at another conference.
Oh, wow. Wow. You'll meet him for the first time. Interesting.
Yeah, well, I mean, we've exchanged 100 emails and talked on the phone at length. And but yeah, I'm looking forward to meeting him.
Is it the conference that he and several people have organized in California? In Berkeley, yeah.
It's in Berkeley on January 13th. Yeah, it's plurality, basically a conference on plurality. And I'll be talking about basically the connection between plurality, quantum mechanics, and rock, paper, scissors. I added that to my 10-minute talk because I realized that, the mystery of quantum mechanics has to do with the imaginary numbers, and that's what leads to phase and phase interference and double slit phenomenon and all that. And I was searching for something in social science that in decision theory that might have this same chirality as e to the I theta, a twist to the left or a twist to the right. And I was talking with a good experimental physics friend of mine, Charlie Marcus, and we sort of settled on this idea that rock, paper, scissors exemplified the cyclical ordering rather than ordering according to a potential function. And when I looked in the ecology literature, I found out that for the last 20 years, the economists have been screaming up and down about how ubiquitous rock, paper, scissors seems to be. It seems to be the explanation for why there is so much biological diversity. 1 million species in a shovel full of dirt. If everything was based on a linear potential function, who is stronger than whom? If you thought of fitness as climbing a potential, then you'd only have a handful of winners. You wouldn't have millions of them. But I think it's the cyclicity and the order that leads to a dynamic stability.
Okay, so it's the randomness of the cyclicity that leads to the multiplicity.
Well, there's certainly stochastic elements, but if you look at simulations, there are beautiful simulations on the internet of rock, paper, scissors. If you watch it spatially, these are cellular automata.
Okay.
You can see that if you only had 2 species competing, there might be a crash. Then you'd be following these Legata-Volterra equations. But if you have 3 species with a cyclical relationship, then there's a natural feedback where as one starts to die out, all of a sudden conditions for it become more favorable.
Well, we'll get into this in a little while, but one of the challenges that my mind can't seem to grasp, apart from what you just said now, it seems to me that trying to connect economics or human behavior to this level of abstract math, maybe it's trying to connect the wrong level of abstraction, or maybe we're trying to think on the wrong level of abstraction. I'll get into the details later of what I mean by that, but isn't that a challenge though? Even if it is connected to rock, paper, scissors, what is the significance of that for political theory or for ridding the planet of nuclear weapons?
Right. Yeah, so, this whole, actually all of economics was rocked, by Kahneman's work a couple decades ago, who, as sort of following your line of thought, was saying that we can't really trust the assumptions of economic models, because people don't think that way, that people's thinking is very broken. So how can we use, mathematical equations or rigorous deduction to conclude anything about economics when the individual participants, the agents, are apparently irrational. And then I was led to this book, Enigma of Reason by Mercier and Sperber, which had sort of a different take on our thinking process, that it wasn't that we were bad analyzers of data, as Kahneman suggested, but that our intelligence was much more specific to argument and defense, and it was collective, sort of pluralistic.
Oh, I like that.
It was that, basically, they said our intelligence didn't evolve to solve Aristotelian syllogisms. It evolved to get out of trouble. Mm-hmm. Someone in your tribe comes up to you and says, you took too many bananas or whatever, and you have to say, well, I'm the hunter and I needed more energy and I'll bring you back a hare or something, So, so they have a kind of a different view of what our capabilities are and how they evolved. And when you ask,
sorry about that. I'm sorry to interrupt. Based on what you said, I really like it, especially the idea that we've got to collectively confront the challenge of the nuclear weapons. No, I think you're absolutely right. It goes beyond the typical Aristotelian syllogism to a new age of sharing information and making collective decisions. So I apologize for interrupting.
No, but I think that's a good point. So, I think your overall concern, which is mine too, is that the real world is very messy, and deep abstraction may just sink into the mud and not be very useful. Knowing string theory might not help you improve the function of the EU. But on the other hand, there may be things to learn about the dynamics, thinking about ecology and thinking about condensed matter physics, dynamics and equilibrium, and what are natural arrangements, what can be self-reinforcing and operate effortlessly. For example, my fear about pluralism is that it could feel like comparing insurance policies, because for the citizen to make the necessary inputs to all the groups that he or she belongs to,
sure,
it's a very taxing job. It's like filling out forms comparing insurance policies. It's would you prefer this combination of results at this cost or this other combination? Sure. So there's like a bounded rationality problem. But on the other hand, bacteria competing in the soil, they don't worry about bounded rationality. They just do what's natural. And if something like rock, paper, scissors produces some stability in their populations, maybe this is something we can import into our own human ecology, which is our social and economic relations. We can import structures that will correlate with increased stability and maybe increased equity, and not equity in the sense of cash, but equity in the sense of social justice. There may be positive outcomes that we can make more likely by setting up structures that have statistical properties that would favor this.
Okay, excellent. Can we contextualize this against the backdrop of your talk your talk in Columbia?
Yeah, please.
If it's okay, I'll share my screen again. Okay, so here, okay, actually we did not talk about, let me take a step back and ask you before, because I think this is super interesting. Can you take a few minutes to tell us about your own, how you see it from your perspective, your own career, your own life choices, the Fields Medal, and how it relates to now your work with Glenn Weyl and quadratic financing?
Well, yeah, I've had a long path, which probably is true for everyone who's 71 years old.
Mm.
And I don't really identify with the young Fields medalist anymore. In fact, sometimes when I hear that accolade, I think, oh, who's that? That was quite a different person. I mean, I started out very single-minded in mathematics. Very narrow focus. It was something I was good at and loved. And really until my mid-40s, pretty much just did topology. But then I got interested in mathematical physics, in condensed matter physics, around the problem of building a quantum computer. And this was actually before I knew the word quantum computer. And it was, so this is in the late 80s.
Wow.
Mid and late 80s. But I had the idea that, which, is the basis of quantum computing, that quantum mechanics offered another model for computing. I thought of it in terms of topology because Ed Witten had just explained what's called the Jones representation. The Jones representation is something in mathematics that describes how a small Hilbert space moves around when you braid excited particles or anyons, excitations of a medium. That's sort of the physics language. In mathematics, these were called simple objects of a tensor category, a modular tensor category. So there was different language, but I got interested in the computational potential of physical systems. And then I actually was so interested in this, I left the academic world and went to Microsoft, and for a while ran their program on quantum computing, and became mostly immersed in physics for those decades. But in the last 5 years, I'm back doing research. The project is in very capable hands, but not mine. And in this more leisurely life, where I was doing research, not trying to build something, and looking in different directions, I found that this idea of quadratic voting was something I could think about. Quadratic finance, let's see, I'm trying to remember Glenn's phrase for this, digressive proportionality. It's all these ideas for bringing quieter voices to the fore and making decisions and arrangements that are more equitable and on net more productive. So it seemed like a new domain, and I've always been restless, and moving into new domains has usually worked well for me.
Okay, well, thank you for sharing that. I think obviously Glenn and his team are very happy that you joined the fight. No? Okay, allow me to now share my screen once again, and this is this is the blog post, right? That
Yes.
Kind of started your collaboration with Glenn. Can you elaborate on the experience and the process?
Oh, yeah. I mean, I'm very happy to, because this was sort of the most exciting moment for me in this whole process. When I started talking to Glenn about everything quadratic, he said I should read this paper that he wrote with Buterin and Hitzig maybe 2 years earlier on quadratic finance, and get the context and see the differential equations and how they solve them and all that. And the thing that struck me in this paper was just a small line saying that you could think of an equation from which you could deduce quadratic finance as its solution. It was an equation for judging the social benefit of a allocation function. So you have individual contributions the individuals are willing to contribute to projects. And then you need a mechanism for turning that into a decision about a social allocation. How much should the community put forward, giving this individual, this sort of voting or sampling of individuals? And basically, they said that you could reinterpret this equation as Kant's categorical imperative. And I thought it through and I agreed. And then to me, this was an astonishing moment, because I'd grown up with my father, a philosopher really, whose main interest in life was Gödel's theorem and logic and the history of philosophy and logic up to Gödel. And, you know, he had the same project as Spinoza, my father did, which was to deduce how to act in the world from a set of starting points. Spinoza wrote about this in his Ethics. And my father spent the last 20 years of his life on his ethics. And he wanted to use his mathematical knowledge to push Spinoza's program forward. And frankly, I'm not able to judge how much progress Spinoza made or how much progress my father made, but I was never able to understand any example from Spinoza's writing. I was never able to follow any single deduction that you should behave such and such because of a mathematical principle. I didn't know the definitions he had in mind. I couldn't understand the meanings of his words. Maybe it was my mathematical mind that prevented me from just relaxing and going with the flow, but I did not see a concrete instance of this goal. And with this remark that quadratic finance could be deduced from categorical imperative, I thought, wow, now I have a concrete example of this very important philosophical goal that's obsessed philosophers for millennia. And, you know, I wanted to see where it led.
Excellent, excellent. Okay, on this slide, this is also from the same presentation. Can you elaborate, please?
Yeah, I can't actually read the text of the slide, but which aspect would you like me to elaborate on?
I'm sorry, can you see the slide or
I see the pictures, the three pictures, but the print's too small to read. So I don't know, I don't want to answer the wrong question. So I just, would you like me to elaborate on like my own background or what the equation is, or what is your question?
I'm sorry. Maybe you're looking at the wrong, the different
Oh,
slides.
the slide I see in front of me has portraits of. Oh, there we go. Now I see an equation. Is that?
Yeah,
is that
yeah. This is the one.
Okay,
yeah.
great. Yeah. So there's a lot of notation in this slide. You know, this is just kind of pulled from a paper, but the way quadratic finance works. So maybe just for the audience, I should back up with that. Is if people are willing to make certain contributions to a public good, like a park or a plan for cleaning up the water or air, then instead of like the charitable giving model where everyone just puts in their contribution and then the total is how much the group has to spend, quadratic voting or quadratic finance says that these dedicated contributions should be square rooted, summed together, and then squared. And that's the answer. That's how much the society or the community should be spending on this project. Of course, you'll notice that that might come out more than the individual contribution. So there has to be backed up by some taxation scheme, which there could be a feedback on how that changes people's preferences. And this is, you know, an area of ongoing research, and it's discussed in the Buterin et al. Paper. But these functions that you see on the slide are in quadratic voting turn out to be that, or quadratic finance turn out to be that square root and square. So if you look at the very bottom line where it says h is the square root of y and g is the square of x, that codifies this idea that the scheme, the mechanism G, takes the contributions CI from each of the individuals, square roots them, adds them, and then takes the square. So that's like the numerator on the left-hand side, but notice that it's been varied. We've written there the partial with respect to one of the contributions. And on the right-hand side, what you see is the individual contribution divided by the sum of the community contributions. Now, the point is that categorical imperative says that a person should act according to a rule that he would be very happy, he would be very pleased if that was universal, if everyone was using that same rule to make decisions. So in other words, it says you shouldn't act from a perspective of uniqueness or exceptionality. You know, this kind of toxic American exceptionalism, for example, you know, America first or whatever. We should think of ourselves as equals. We should approach the world that way. And that's codified by this equation because it says that the weighted contributions, the H of C's, should be adjusted in such a way the sum is the sum is representing the idea that everyone in the community should recognize that the same adjustment for more clean water is necessary that the individual has, and that gives the sum on the right-hand side. So it's saying that you adjust the commitment to the social good according not just to how you are willing to vary your contribution, but presume that the society is willing to follow your precept.
Okay, excellent. And this slide is where you make the famous connection, no, between this concept and quantum mechanics. Can you explain?
Well, yeah, so wormhole is just a beautiful metaphor, I think. It was actually in the press recently to describe some 9-qubit experiment.
Yes, of course. Of course. Yes.
But you know, here we're using the wormhole as a loose sort of science fiction-y idea. It's a way to get from distant realms very quickly. So, you know, people think of it as like a puncture through space-time that allows you to take your spaceship through from one to the other. And this was actually Glenn's metaphor for, is there any way to transport ideas back and forth across the wormhole? That is, could we take concepts in quantum mechanics and say, well, there's an analogous question in social engineering. Can we bring the calculations and the concepts from quantum mechanics from one side of the wormhole to the other? Or perhaps a little less likely, but also possible, is that an idea on the social side could inspire some rigorous concept in the more mathematical world of quantum mechanics. You know, that's not entirely unknown. An important tool in optimization, even in pure mathematics, is this Ford-Fulkerson algorithm for related to solving max flow min cut problems, which was invented in economics, and you know, has gone through a wormhole and comes out in quantum gravity and in other places in differential geometry and math physics.
Oh, very interesting. I did not know that. Is that similar to the concept of a top-down approach to quantum gravity, or for example, Yakira Harnab talks a lot about top-down causality. Is it a related concept, or is that completely different?
No, I think it is different. I think it's in a way elementary. There's an idea which has been put forward for the last 20 years by Leonard Susskind at Stanford, that quantum entanglement is kind of a micro hole, a micro wormhole. When you have two particles like up, down, minus down, up, they're spin entangled. He visualizes that as some kind of non-local connection between them.
Okay.
And this idea is now become mainstream in connecting quantum information and quantum gravity. You see a lot of papers on quantum gravity where they exhibit like a hyperbolic geometry design, like an Escher picture of tensor networks filling up the hyperbolic space. And the idea is that entanglement of states on the boundary, the CFT, go through the bulk, the ADS, through entanglement across these networks. And these lines, these connections of tensor legs are the, actually, I called them in a paper I wrote 10 years ago with Matt Hedricks, we called them bit threads, though you might call them qubit threads. So the idea that quantum information and quantum gravity are tied has been pretty extensively studied. So, we'd like to ask whether any of these ideas could be transported back into the social realm. And I think the first thing that we sort of settled on, Glenn and Weyl, Fabinger and I, as like the key test, is to properly interpret the notion of phase on the social side of the things. That is, the crux of quantum mechanics, what made it so hard for people to understand is the thing that is added in quantum mechanics is not probabilities, but what are called probability amplitudes, or just amplitudes. And you have to take norms squared of these to get a probability. But the things that different pathways contribute to and should be added accordingly are the amplitudes. So amplitudes can interfere with each other by having a phase. In probability, if two things are if something's likely in two situations and both situations are manifest, then the fact that the possibility it'll turn up increases because it could happen either this way or this way, and they add. But like in an optical experiment, if you send a photon through a double slit, if there's a phase difference, even though there's a strong photon signal going through both slits, they can cancel out and produce a node, a dark spot on the film. So I'd say that's the essential feature of quantum mechanics. It's the imaginary numbers and the possibility of cancellation of phase. And the three of us set out on a mission to figure out how phase could be relevant in economics and in the social world. And I'd say it's a quest, and anyone welcome to throw in their ideas, because we don't know the answer. We're just exploring this as a problem.
Okay, great, very interesting. Okay, and from that work, you finally end up with what you call quantum quartic finance. And as you see on the slide on the screen, yes. Can you elaborate on going from your work that posited the wormhole until this final equation?
Yeah, so what we decided to do was study a model where we just shoved in the phases artificially and saw what happened. So if you compare the first formula on this page with the one we were discussing a few slides back, this formula has fourth powers, where the other one had second power. But what you'll see is those omegas. In order to match the equations in your head, you can forget about the p's for right now. The p is an index that runs over the product or the good that you're trying to fund, and we can just consider one such good. So the important index is the I, which runs over the citizenry. And to put it in a nutshell, what we're seeing here is that if you have these random phases, there's a very familiar phenomenon in randomness called the central limit theorem, which always involves a square root. The most basic example of this is a random walker. If you have, sometimes it's called a drunken walker, a person, say, moving in the plane, taking unit steps, but in random directions. And you ask in expectation, how far is he from his starting point after 100 steps? Well, the answer is he's likely to be about 10 steps away. It's a square root rule. And what happens is if you insert random phases in the allocation formula, this square root interacts with the fourth power and brings it down to effectively the square that we're familiar with for quadratic voting. So what we did in this paper is we explored how altering the standard models with random phases, still without knowing what those phases would mean, we asked how that would change the optima now an expectation value, how the optima would change. And what we found is that the second powers go to fourth powers. And there's a D in this formula, which has to do with the dimension. The dimension that is most interesting to me is D equals 2. That's what corresponds to complex analysis. But if you were interested in quaternion phases, then D would be 4. And if you were interested in general signal models instead of algebraic contributions, then D could be any number.
Okay, so some open questions. Some of them you've already talked about. And what do phases mean in economics? No, of your work. What do phases mean? And from your paper itself, our goal is to understand the analogy between the norm squared of the sum of amplitudes and the sum in weighted contributions in quadratic finance and quadratic voting. So, am I right, based on this and based on what you've said today, that this is the primary challenge at the moment? At least
I think so. I mean, what stares you in the face is this mathematical accident or phenomenon, we don't know which it is, that the rule in quantum mechanics involves squaring the sum of the amplitudes, and the rule in quadratic finance involves squaring the sum of the weighted contributions. So is that square accidental, or is there a deeper reason that it's that it serves both worlds? So we want to understand that. And I'd say the second thing we want to understand is the role of phase, because that's maybe the most singular feature of quantum mechanics is the ubiquity and importance of phases. And in economics, usually you have plus signs, sometimes minus signs, like, someone might vote against a park or make a contribution to stop something. So I think in economics, it's very well established what plus and minus mean, but what does I mean? What's the imaginary number mean?
Excellent. Okay. So some questions or some objections, more questions.
Yeah.
Does it not promote self-interest? The proposal, doesn't it make humans, it allows humans to vote their preferences more? Is there some sense in which it's actually promoting people to be more self-interested?
Well, that's interesting. Yeah, I think we always have dealt with human self-interest to the level of the individual. I think what's pernicious in the last 20 or 30 years is the development of group interest as such a central focus in politics. Tribalism. And I think whatever mechanisms we converge on, I would think that they should discourage tribalism. I think that we have to develop a feeling across humanity that we have primarily a shared interest, and that we're more alike than we're different. I don't see these quadratic mechanisms as promoting self-interest beyond the fact that they more accurately do assess the interests of the individuals. They give them more opportunity to express their interest.
Okay, so is it unjust? Some people have objected that it's unjust, that some people naturally have an advantage under quadratic voting or quadratic funding.
Well, yeah, so another thing that was very interesting to me in this first pass through the subject consequence of that Kant's categorical imperative is that the formula quadratic voting seemed to be halfway between sort of brutal American style capitalism, you might say, and Mother Teresa egalitarianism on the other. You could say everyone has an equal voice in deciding funding of public goods, regardless of what their own financial status is. And what quadratic voting seems to say is an efficient answer is to let people speak to the square root of their financial resources. So it's, in other words, it's halfway. It's halfway between the Senate and the House of Representatives, if you like. It's each state is not equal, but it's not exactly proportional to population. It's a compromise, and this is what Lionel Penrose had in mind in his 1946 paper when he introduced quadratic voting. That he gave a mathematical argument in that paper that it was the fairest, and his justification was that it gave each citizen of polities, regardless of their relative size, the same probability of tipping the balance of decision. That was his motivation in the 46 paper. So it's not totally egalitarian, and it's not totally, hard capitalism, survival of the fittest either. It's a median between the two, and maybe it's the happy median.
Okay, excellent. So I mentioned this earlier, maybe trying to understand what phases are economically is a wrong level of abstraction. Or should quadratic voting, quadratic funding be governed by nested levels of hierarchy? I think you've already hinted at this. The idea that quadratic voting or quadratic funding might be good for some things, but not good for other things. If we had more time, it would be interesting to hear your thoughts about how to differentiate when it's good and when it's not as good. No? And you also
perhaps could be used hierarchically, as you say yourself. That maybe these decisions have to go through rounds which aggregate opinion in larger and larger groups. I don't know.
Yeah, I think that sounds logical and reasonable. Okay, and also if we take nature as our inspiration, that seems to be also something reasonable to investigate. And the last point, you did mention something earlier I found fascinating. My question was, quadratic voting, quadratic funding is based on physics, but does it add anything to physics? And you raised a very interesting point that maybe quadratic voting, quadratic funding can actually add something to quantum mechanics. I think that's really, really interesting idea that I would certainly like to know more about at some point.
Well, I would like to know more about it too. I don't know what can be brought in that direction through the wormhole, but it would be great to find something. Quantum mechanics has spawned dozens of interpretations. It's a whole subdiscipline in philosophy. One that appeals to me a lot is developed by Zurich and his collaborators, which he calls quantum Darwinism, which is sort of a survival struggle for recording oneself, where the self here is just an elementary process. It's recording. So most of what happens in the universe disappears because the universe can't remember everything that's happened and still do new things. But Zurich sort of postulates a struggle to be recorded. It's like an existential angst at an elementary level. It's a very curious starting point. And I've wondered whether quadratic thinking could lead to a modification of it, where it's not so much a Darwinian struggle, but some kind of collective effort, more pluralistic than Darwinian. But I'd say the jury's out. I mean, we need to keep thinking.
Well, a good point. A good question, or a question, I'm sorry. Of all of the different interpretations of science in general and quantum mechanics in specifically, would you agree that whichever interpretation ultimately makes it less possible for us to go into some kind of disaster, cataclysmic proportion, that interpretation is more promising than an interpretation which is silent on the question or cannot say anything about it?
Yeah, that's interesting. As a scientist, one tries to stay divorced from the consequences of one's interpretation. That is, you try to find the most parsimonious interpretation in some ways, but it might not be edifying. For instance, Everett's all possible worlds, parallel worlds, is in some ways parsimonious, in some ways extravagant. It's extravagant because of all these worlds, but it's parsimonious in that you don't have to come up with answers for things like, well, where did the unrealized probabilities go when you make a measurement? Because they just went off into the other world. But I've never thought that, but that's kind of a fatalistic, that may lead to a fatalistic mindset that everything happens. So why try to intervene and prevent a bad thing from happening? I think that was sort of the meat of your question. Is there a way of thinking about the knowledge we have, a mindset that will help us move forward in a constructive way? I mean, that's an interesting attribute of a physical theory that hasn't normally been considered in science, whether it's beneficial to our psychology.
Well, it seems reasonable. Certainly, if you have two theories, for example, the many worlds theory, which says absolutely nothing about our existential dilemma. Of course, as a scientist, in theory, we're not supposed to care about this, but as a human, it just seems unacceptable to say, I have one theory about quantum mechanics that is consistent with experiment, or I have two theories. Both of them are consistent with the math and consistent with experiment, but one of them leads me to get rid of all the nuclear weapons on the planet, and one of them says absolutely nothing. Says, don't worry, there's many other universes where there's zero nuclear weapons on the planet. It seems like a no-brainer to say, obviously, we want the one with, in this world, the one that we're involving in now, we want the theory or the interpretation that's going to help us get rid of the nuclear weapons on the planet.
Well, something I think we have to face is that we may never know like a correct interpretation. It may be a philosophical issue how the mathematical equations can be expressed in philosophical terms, and there may be a matter of taste. And even at the very hard physics level, there's a phenomenon sometimes referred to as screening of the ultraviolet. What it refers to is the idea that there's no experiment that you could imagine doing at low energy that might distinguish two different high energy theories. That is, by renormalization, once you get down to the energy scales that humans can achieve, like even at the LHC, at these relatively low energies compared to fundamental energies, that maybe two theories have already converged and are not separable by experiment at our energy scale. So I think, part of exploring physics is to be humble and know that there are things that we will not know, that we will not be able to chase down. So if that gives us flexibility to adopt a moral view that's better for us and better for the survival of the world, I agree with you. Seems little cost in taking that choice.
Exactly. Well, Dr. Freedman, thank you very much for taking the time to talk today. I just want to repeat how grateful and inspired I am by your work with Glenn Weyl and your efforts to improve our situation on the planet. I think it's a nice way to kind of not culminate, but kind of bring additional fruits to your many years of work in math and working on the common good in general. Fantastic.
Thank you so much. And I appreciate this opportunity to talk to you. And looking at some of your previous interviews and your website, I'm very impressed by the work that you're carrying out. So let's stay in touch.
Fantastic. Thank you so much.
Bye-bye.
To support our discussions with the world's leading thinkers, please see the video description or visit eism.eu/support. Thank you.